Section 3.1, Graphing Linear Equations. Our essential question today is how do you determine if an equation represents a linear or nonlinear graph? The key word in this essential question is equation, because we are going to work on graphing today and figuring out from looking at a graph if something is linear or nonlinear, and then we are going to ask you to go back to the equations to determine what you see in the equations that cause you to think a graph is linear or nonlinear. Linear. If you look at the word linear, the first 4 letters tell you everything you need to know. The first 4 letters spell the word line. So if something is linear, its graph is a line. Now, students usually say that it's a straight line. Well, all lines are straight, and they continue in both directions forever. So it could be a diagonal or oblique line. It could be vertical or horizontal. Those are all examples of lines. The next vocab word is nonlinear. The prefix non, I'm pretty sure you know, means not. So nonlinear means that the graph is not a line. Now, being a nonlinear graph can mean a lot of different things. The graph might be curved like this, might be curved like this, curved like this, or it might even take the shape of, say, a V or an angle, which you may be confused when you compare to a line because it's not a straight line, it's got a bend in it or a vertex point. It's actually more like an angle with 2 rays. So those are all examples of nonlinear graphs, and of course there are a lot more where those came from, okay? So basically, linear, your graph is a line. Nonlinear, it's everything else, everything else. Okay, now we are going to take 3 different equations and we are going to graph them. We're really hoping that this is review for you, that in your previous math classes, last year or the year before, we're really hoping that you learn how to take an equation and make a table or a T-chart for them. And then graph them, graph those ordered pairs, and take a look at the graph, and then answer the new question, is it linear or nonlinear? And answer the question that comes from chapter 1, is it a function? You remember chapter 1, the vertical line test, where we drew vertical lines through the graph to be able to tell if it would pass the vertical line test. Or remember no repeats in the domain. We used that as another way that you could tell if something is a function or not. All right, so let's go. Our equation says y is equal to 2x plus 1. So y equals 2x plus 1. I want you to think about, when you make this table, think about which variable you should start with, which one you should start with, which variable is independent, so that you've got some choice with that variable. Hopefully, you know that variable would be x. X is independent. It happens first. And then the value of y depends on what you're putting in for x. So y is dependent on x. X is the independent variable. I am going to pick 5 different values for x, ranging from +2 to -2. When you choose your values, it really is your choice. I would prefer that you choose some positive numbers and some negative numbers, because you're not necessarily going to see the shape of the graph if you go with all positive numbers. And that will probably make a little more sense when you start working on your homework assignment, your worksheet. So sometimes if you pick only positives, you're just getting part of the graph and you think it's linear when it really is not, okay? Now, I'm going to plug these values in one at a time. Y is equal to 2x plus 1, so that means 2 times whatever x is. So on this one it's 2, and then you have to add on the 1. 2 times 2 is 4, plus 1 is 5. The next one, back to my rule. 2 times whatever x is, now it's 1. Then plus 1, 2 times 1 is 2, plus 1 is 3. Next one, 2 times, now we're plugging in 0, plus 1. Anything times 0 is 0, plus 1 is 1. Next one, 2 times. When I plug in a negative number, I try to remember to put it in parentheses so that I can make sure I see that negative sign. 2 times negative 1 is negative 2, plus 1 is negative 1. If you're not so strong with your integers, please use a calculator to double check on those. The last one, 2 times negative 2, plus 1. 2 times negative 2 would be negative 4, plus 1 is negative 3. Now we're ready to graph. Remember that in this table, what we have found are ordered pairs. We have found ordered pairs. So in case you need to look at them as ordered pairs, I can just show you that this first one would be x was 2, y was 5. So 2, 5. The second one would be 1, 3. Third one, 0, 1. Negative 1, negative 1. And negative 2, negative 3. You don't have to write them as ordered pairs as long as you understand how to graph. So 2, 5 is right 2 because it's positive, and then up 5 because y is positive. 1, 3, right 1, positive x, up 3 for the positive y. 0, 1, this is where we see the most issues with graphing when one of your coordinates is 0. 0 is x, which means I'm not moving left to right. And then the 1 for y means I have to go up 1, right here on the y-axis. Then negative 1, and negative 2, negative 3. So if I connect these, you should see that they are in a straight line. So here's my line. I put an arrow on each end. These lines go on forever. And there's my graph. Now, let's answer these questions. Is it linear or nonlinear? This one is definitely linear. Is it a function? Would it pass the vertical line test? If I drew vertical lines through, does each one touch only once? Yes. So that means it's a function. So I call this a linear function. And that's it. We've answered both questions. The next example, this one has an exponent in it. So y equals x squared plus 3. X squared plus 3. So this equation looks different than the last. Okay, so I'm going to still go with my same values though. I like those values from the last one. 2, 1, 0, negative 1, negative 2. So I'm going to stick with those. Now, when I plug those in for x, I am going to have to put the exponent on the number and then add 3. So 2 squared is 4. 4 plus 3 is 7. So that ordered pair would be 2, 7. 2, 7. The next one, I'm substituting
Amy Lucas,
1
call
for
6809.
x.
Amy Lucas, call 6809.
1 squared plus 3. 1 times 1 is 1, plus 3 is 4. So 1 plus 3 is 4. So my ordered pair, 1, 4. The next one, I substitute 0 for x. 0 squared plus 3. 0 squared is 0, plus 3 is 3. So this ordered pair will be 0, 3. Now we get to the tricky ones. If I substitute a negative 1 or a negative 2 and square them, I want you to think about what happens when you square a negative number. Negative 1 times negative 1 is positive 1. Negative 1 squared is positive 1. Negative 2 times negative 2 is positive 4. A negative times a negative is a positive. So then both of these, you add on your 3, and you get 4 and 7. So when I graph these, You may already be thinking about this. 2, 7, 1, 4, 0, 3, negative 1, 4, and negative 2, 7. This is non-linear. This graph is not a straight line. It's not a straight line. It curves. This graph is actually called a parabola. We will learn a lot about parabolas later in algebra. Chapters 7, 8, 9, maybe even part of 10. We will work a lot with quadratics. Quadratic equations are equations where you've got a variable with an exponent of 2. Quadratic equations create graphs that are parabolas. They have a vertex point that's pretty special because it's on the line of symmetry. You may notice that this parabola has symmetry. This y-axis right here splits it right in half. The only point on that line of symmetry is the vertex. Every other point on the parabola has a mirror image on the other side. So it's kind of a cool graph. All right, our last one. This last one, we've got absolute value. Y equals the absolute value of x minus 3. So if I stick with my same five values to plug in, the absolute value of 2 is 2. 2 minus 3 is negative 1. Absolute value of 1 is 1. Minus 3 is negative 2. Absolute value of 0 is 0. Minus 3 is negative 3. Now the negative numbers. What happens when we plug in these negative numbers? The absolute value of negative 1 is positive 1. So 1 minus 3 is negative 2 again. You might have been thinking there was a pattern here for y. Negative 1, negative 2, negative 3. Maybe you were expecting a negative 4. But it's not. It's back to negative 2 again. And the last one, absolute value of negative 2 is 2. Minus 3, negative 1 again. So this shape is going to look a little bit different. Be careful when you're graphing. 2, negative 1 is down here. 1, negative 2. 0, negative 3. Negative 1, negative 2. And negative 2, negative 1. So this graph is a V shape. V shape. Similar to the parabola because it's got that axis of symmetry that splits it in half, but there's no curve to this graph. It's like 2 rays put together or an angle even, if you don't want to think about the V shape. So an angle, 2 rays, or a V, it is non-linear. It is not a straight line, non-linear. And does it pass the vertical line test? Absolutely. So it's a nonlinear function. Nonlinear function. Now, I'm going to go back to the last one because I'm pretty sure I didn't write that. This one is nonlinear. It's not a straight line. And it passes the vertical line test. So it is a function. So all 3 of these are functions. One of them was a linear function. The other 2 are nonlinear. Now, to answer your essential question, you've really got to be thinking about that key word being the equation. The equation. So what was it about those equations that caused the graphs to be nonlinear? So I want you to go back and look at the 3 equations, look at the one that was linear, and look at the 2 that were nonlinear, and try to come up with a reason that happened based on what you see in the equations, okay? So not based on looking at the graph. And then your homework is a worksheet with 8 problems on it. And when you work on that worksheet, I'm going to give you a couple of hints. So the regular numbers, 2, 1, 0, negative 1, and negative 2, those are going to work just great on number 1, number 2, number 4, number 5, number 6. Those are going to work great, okay? On number 3, I'm pretty sure that because you're dividing 4 by something, let's see, you cannot divide by 0. So I'm thinking that you want to go with, on number 3, you want to go with 4, 2, 1, -1, -2, -4, okay? And then on number 7, you are going to want to go with, it's a square root. So you want to go with numbers that are perfect squares. So I'll let you think about that. Think about some numbers that are perfect squares. You cannot have any negatives. So no negative numbers on that one. You cannot take the square root of a negative number. And then on number 8, because you've got a fraction and the denominator has a 2, let's see. I would go with some numbers like 4, 2, you want even numbers on this, 0, -2, and -4. And that should be good.